Okay, so we're in chapter 1, section 4. We're going to start talking about graphing lines. Right here at the very beginning, we got a quick reminder of how to calculate slope. We should all be familiar with the slope formula. It's here on the board. And then a couple more things that they want to talk about. If you ever have a horizontal line, we should know right off the bat the slope of that line is 0. And a vertical line, straight up and down, has an undefined slope. Okay, so our first problem here asks us to find the slope of a line that contains the points 1, 2, and 5, negative 3. So if I'm given 2 points, asked to find the slope, I'm just going to use that slope formula that we just looked at. y2 minus y1 over x2 minus x1. I just have to identify which variable is which. I'm going to call this x1, this one y1, this is x2, this is y2. Alright, substituting again, I get y2 minus y1 over x2 minus x1. Okay, and that simplifies to be negative 5 over 4. So the slope of the line is negative 5/4. Notice that we like to keep our slope as an improper fraction. Don't change it to a decimal or a mixed number. Right? And negative 5/4, that can be rewritten as a big negative 5 over 4. That's probably the way you see it most times. But it's the exact same thing, just a notation difference. Okay, so the next thing they want to review is the slope of the line and what it looks like if that slope is positive or negative. Okay, so a positive slope on a line means as I view the line from left to right, it's going to be increasing, right? And we'll see that a lot. So this line here has a positive slope. Right, if I have a line that as I look at it from left to right is decreasing, then this line has negative slope. And that we talked about just a second ago, if I have a horizontal line that's not rising at all, then this has a slope of 0. Okay, now looking at example 2, it asks me to graph a line, or actually it's 2 lines. They both contain the point 3, 2, but we have different slopes. Okay, so the first line we're going to be dealing with has a slope of 3/4, and the second line we're going to be dealing with has a slope of negative 4/5. But they both go through the point 3, 2. Okay, so let's find where that point is. So I start at the origin, I go right 3, I go up 2, and right there is my point 3, 2. Right? Now, here's something that I see messed up quite often. If I'm asked to, or especially early on, I don't know why it's messed up as much as it is. I'm using a slope of 3/4. That means what? From my previous point, I'm going to rise 3 and run 4. So where do I need to go to draw that graph? I go to the point that is known. I go to here. All the time at the beginning of this class, I see people go to the origin and try to rise 3 and run 4 from the origin. That's not what we do, right? I know it's a mess up, but it happens. We go to our known point, which is here. And from there, we're going to rise 3. We're going to run 4. And we find a point right there. Now, all you need is those 2 points to make the line. But if you're like me and you're not very good at drawing a straight line, it's okay to get some additional points. And I would probably recommend that. Just so, in case your line isn't straight, I can look at it and say, well, I know they're trying to draw a straight line, but I see all the points they're trying to go through. Right, so I went down 3, left 4, which is the same as going up 3, right 4. And so right there is that line. Okay, now my second line, has a slope of negative 4/5, but it also goes through the point 32. So I'm going to start here at this point 32, and I'm going to use negative 4/5. Now, like we talked about before, I'm going to move the negative to either the numerator or the denominator. In this case, I'm going to put that negative in the denominator because where my point is, I can't go right 5. I would go 1 off the graph. Okay, so I'm going to try to go left 5. So when we do that, from this point, I'm going to rise 4. I'm going to go left 5. And I get the point right there. Okay, and like we said, the other point, you could go back to that red point, go down 4, right 5. It puts you somewhere right here. Okay, just off the graph. But then as I draw my line, oh, let's try that again. It'll be something like that. Okay, the next thing we're going to look at are those two special cases that we talked about earlier. Those would be a vertical line and a horizontal line. Okay, and we're transitioning now into not just talking about the slope, but we're going to be talking about equations for these lines. Okay, anytime you have a vertical line or a horizontal line, the equation for that line is only going to have one variable. Okay, if it is vertical, the one variable it's going to include is x, and your equation looks something like x is equal to some number. Okay, and then for the horizontal line, the one variable included is y, and the equation looks something like y is equal to some number. So just remember, in those two special cases, your equation will only have one variable in it. For all the other ones, there will be two variables. Okay, here in example 3, I'm told to graph the equation x equals 3. Now, by this time you're in pre-cal, you probably can do this with no problems. But I still like to explain it because I know some struggle with it. So I'm going to tell you how I finally learned how to get it straight in my head. Because I used to get confused, should it be vertical or should it be horizontal? And I would miss it early on. So this is my thought process. If I'm told to graph where x equals 3, I'm going to go on my graph to where x is equal to 3. So we know this is the x-axis. So where on this x-axis is x equal to 3? That would be right here. Right? Now, pick any other point where x is equal to 3. Well, if you think about it, say if I pick this point here, what's that ordered pair? 3, 2. What's x equal to? 3. Do you get that? Same here. That's 3, negative 2. 3, negative 4. All of these are places where x is equal to 3. So my line is going to be a vertical line. Now, maybe by this point you can look at it and you remember x equal is always vertical, y equals is always horizontal. If you do that, that's good. And hopefully we can get there before the end of this year if you're not. But if you have to think about it, that's a good way to go about it. Here's the next form of an equation we're looking at. It's called point-slope form. Okay? The one you're probably most familiar with is slope-intercept form. We're going to talk about that later on in this section. But for now, point-slope form. When do you think is a good time to use point-slope form? Like, when would this be good for you?
When you have a point and you're looking for the other.
Okay. Using point-slope form is really good when you know a point and you know the slope. That's why it's point-slope form. This is one you're going to have this memorized. This shouldn't be the first time you've seen it. Okay, make sure we have that memorized for the test. Okay, so my problem says an equation of a line with a slope of 4 containing the point 1, 2 can be found. Well, I hope it can. So look at what they've given us again. They've given us the slope of the line is 4, and they've given us a point on the line. Given the slope and the point. Point and the slope. Point slope form. Right, so point slope form again is y minus y1 equals m times x minus x1. Okay, so this 1, 2, remember the 1 is my x1, the 2 is my y1. So this is y minus y1, which is 2, equals m, which is the slope, that's 4, times x minus x1, which is 1. Now, is this an equation? Yes, because it has an equal sign. So is this an equation for the line? Yes, so you can stop right there. Now, there'll be problems later on that specify. They say, I want it in point slope form, or I want it in slope intercept form. But for now, if it just asks for an equation of the line, this is a valid answer. Okay, so here we're told to find an equation of the horizontal line containing the points 3, 2. So I'm going to show you a couple different ways you can do it. The first way I'm going to show you is the way the book wants you to do it, or the way that they thought about this. That would be the equation of a horizontal line. So horizontal line have a slope of what? Slope. So I know the, sorry. Yes, 0. See, I told you I'm not on my game today. 0. So the slope is 0. And then I know a point that exists, 3, 2. So what's known? A point and the slope. So I can use point slope form, which is y minus y1 equals m times x minus x1. Okay, you distribute this out. 0 times these things is 0. So I get y minus 2 equals 0. That gives me the equation y equals 2. So you knew a point and you knew the slope, so you could use point slope form. Now for me, what I would do on that problem, I would look and say it's a horizontal line. So I know horizontal lines only have y equals in them. Right? And now what does the y value equal here? The y value is equal to 2. Right? And that would be my thought process. Either way is fine. Okay, let's look at this one. It tells me to find an equation of a line containing 2 points. And then it tells me to graph this line. So, if I'm going to write an equation of a line, what is it that I need? I need the slope, for sure, because the 2 ways we know how to write an equation are point slope form and slope intercept form. So how could I find the slope given 2 points? Good, use the slope formula. This is x1, y1, x2, y2. So the slope is y2 minus y1 over x2 minus x1. So that's 2 over negative 6, which reduces to negative 1/3. Everybody good with that? Now, what do I know? I know the slope of my line, and I know a point on my line. So I'm going to use point slope form. It's amazing. You use the 2 things that are in the name. So this is y minus y1. 3 equals m negative 1/3 times x minus x1, 2. And again, it just tells me to find an equation. It doesn't say it has to be in slope intercept form. So this is an equation for that line. So this is my final answer.